scientific notation. An ordinary penny contains about 20, I don't know how to read that, number of atoms. The average size of an atom is about 0.00000003 centimeters across. That is really hard to read. The length of these numbers is in standard notation that makes them awkward to work with. That's why we will use scientific notation. It's a shorthand way of writing such numbers. In scientific notation, the number of atoms in a penny is 2.0 times 10 to the 22 power, and the size of each atom is 3.0 times 10 to the negative 8 centimeters across. That's easier to read. Helpful hint: the sign of the exponent tells which direction to move the decimal. A positive exponent means move the decimal to the right, and a negative exponent means move the decimal to the left. To write them back to standard notation. Now, let's try. Write the number in standard notation. First, 1.35 times 10 to the power of 5. 1.35 multiplied by times 10 to the power of 5. Times 10 to the power of 5 means 100,000. So it means we're asked to multiply 1.35 to 100,000. So simply, we can just move our decimal point 5 places to the right. So from 1.35, we're going to move 5 places to the right, and that will be 1, 2, 3, 4, 5. So we will end up with 135,000. Next, write the number in standard notation. 2.7 times 10 to the negative 3. Move the decimal point 3 places to the left because we use negative sign. So 2.7, this is our decimal point. We're going to move it to the left 3 times. 1, 2, 3. Then we will just add zeros. This will be our new decimal point, then 0 here. So the answer is 0.0027. Next, write the number in standard notation. Negative 2.0 times 10 to the positive 4. So we have positive 4 exponent. It means we're going to move our decimal point 4 places to the right. So negative 2.01. This is the decimal point. Move to the right 4 places. 1, 2, 3, 4. So we'll just add zeros here. Then this will be our new decimal point. The answer is negative 20,100. Write the number in standard notation. 2.87 times 10 to the 9. Again, we have positive 9. So it means we're going to move our decimal point 9 places to the right. 2.87, 9 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to add 1, 2, 3, 4, 5, 6, 7 zeros there. So our final answer is 2,870,000,000. Last, 1.9 times 10 to the negative 5. Again, we have a negative 5. So it means we're going to move the decimal point 5 places to the left. So we have 1.9, 5 places to the left. 1, 2, 3, 4, 5. So we're going to add 1, 2, 3, 4 zeros. This is our decimal point. So the final answer will be 0.000019. Now, how are we going to translate standard notation to scientific notation? Let's say, for example, let's write 0.00709 in scientific notation. First step is move the decimal point to get a number between 1 and 10. So we're going to move the decimal point to the right or to the left to get a number that is more than 1 but less than 10. So in this case, our number is 7.09. That is less than 10 but more than 1. Next, set up a scientific notation. So it means we're going to put the times 10. Now, what will be our exponent? The exponent will depend on the decimal point that you move. You move it 3 places to the right. So it means the exponent is negative. So we have 7.09 times 10 to the negative 3. Next, write 0.000811 in scientific notation. Again, you need to move your decimal point in the numbers between 1 and 10. So, means this decimal point should move on this part. So we will move 1, 2, 3, 4. So we have 8.11. Next, what we're going to do is to add the scientific notation. So 8.11 times 10. Now again, we move our decimal point how many times? 1, 2, 3, 4. 4 times and going to the right. So it means we're going to have a negative exponent. Now, let's practice more.